Mike. Mike. Come on down. Hey, how you doing, Sam? Awake, almost prepared. Look, man, what kind of wingman are you? Thank you. All right. Welcome to the Beer Working Group. IETF104. This mic is not loud enough. I can't step on you guys and stop you from talking. Even ice isn't stopping talking. It's supposed to be on. Button, louder, louder, louder. Louder. Is that better? We still have people pouring in. It's nice we shut the door. We're in the elevator corridor, which means it'll be loud out there, and we'll be loud for them. We're kind of packed in here. I apologize for the delays on the agenda. I think my Gmail account is so... I can't hear it? I need a louder mic. All right, that works. My Gmail was bouncing. And then some people, sent stuff to Cisco and things like that. But I got it straightened out, I believe. I think the agenda is correct now. I got everyone's deck up. We have 2 sessions, so if there's a whole huge gap, I think we have some time to squeeze things in if I missed them. But I believe everything's up there as of now. I apologize, too. This is our first thing in the morning, so many of you I've not seen yet. So you don't really handshakes and hugs and catching up, and now it's like, let's go. So noted. Blue sheets. We have someone taking minutes already. Thank you very much. Had a volunteer step up right away. How about Jabber Scribe? Anyone on Jabber has like serious passion for Jabber and would love to participate? If you laughed at that, you get called. So somebody, anyone on Jabber right now? Nobody's on Jabber? Can we see if anyone's even there?
Yeah. One person.
Okay.
I can get in.
I was going to volunteer you, but I love the fact you jumped in on your own. That's awesome. All right. All noted. Note well noted. A lot of nods. Everyone awake yet? Should we call for coffee? All right. Agenda. Take a look. Anything's missing, like I said, shout. We got a time slot. Pardon me? Right to my mouth like this. I am your father. So the next on the agenda is Stig. Is Mr. Stig here? Beautiful. Look at that wonderful.
All right. All right. So is this okay? All right. So this is about the beer MTU discovery. So the draft was adopted since last meeting. The idea is to find some stable MTU that can be used within a beer domain with regardless of the path that is taken. There's another draft about path MTU discovery in this working group as well, but this is different from that. Next slide. During adoption, there were a couple of issues raised. One is how to deal with tunnels. If you want to bypass a non-beer router, you might do an MPLS or segment routing tunnel or something. If you do that, then the MTU of that tunnel might be less than the MTU of the rest of your beer domain. So we need to figure out how to deal with that. One option is to just announce the tunnel MTU and just say that whatever tunnel overhead you have for that tunnel will also affect other traffic in the beer domain, which may not be good, but that's something we can discuss. Another thing is, do we discover MTU across different IGP areas? And reading the ISIS and OSPF RFCs, it's kind of hard for me to tell, are we sending beer prefixes across areas or not? It seems to be kind of optional whether to do that. So yeah, so basically, if you want to encapsulate beer traffic to a beer egress router, you need to learn the beer prefix of that router and how to encapsulate the traffic, and what bit set and whatever. So if you receive the beer prefix, then you would also receive this sub TLV that includes the MTU. So it seems to me that the documents talk about flooding domain and so on, but it's not quite clear what the flooding domain might be.
Les Ginsberg. So, at least for ISIS, I think early versions of the draft, we didn't support it, and then we decided to support it. So we definitely do support advertising what's called the node address.
Yeah. Is that an optional thing, whether you leak it across?
Well, it's subject to configuration, typically on most implementations.
Right. Yeah. So at least my understanding is if you leak those prefixes, then you can learn MTU as well. If you don't do that, then you would obviously not receive these sub-TLVs.
So, I mean, the caveat here as far as MTU is you don't have topology information about the other areas. So you don't have information about, what links you're... But if you're talking about the new sub-TLV...
Yeah, so as long as you receive the beer prefix, you would also receive the sub-TLVs that might include the MTU.
Correct.
Right, yeah. So next verse on the draft, we need to have some text, clarifying issues, and I don't know if people have any other issues they want to raise. So I apologize for not trying to address some of this in the last version, but plan to get some discussion on the list and post a new version before the next meeting. All right. I think if these are the only issues people have and we conclude on how to solve them before the next meeting, then potentially the next IETF. Yeah. Yeah, thanks for great comments on the adoption call. Right, but yeah, I'll try to start some threads to discuss this on the list.
So Les Ginsberg again. So apologies, I may not have been keeping up, but have we made some decision about, because there's the path into discovery draft as well. Are the fates of these two things linked at all? Or have we decided just to treat them as independent? So I asked.
At least my take on it, and which also is mentioned in this draft, is that this gives you an MTU that works for the entire domain, which can be like a safe, minimal MTU to use. But if you want to, for certain traffic or maybe all traffic, to do a pop MTU discovery to find like a more optimal MTU, that's possible. I think that's okay, but it would be good if either draft or both drafts have some text explaining the relationship to the other. Yeah. So. Yeah. Or at least we need to clarify why is there for two different MTUs. Yeah.
No, I know both, so both drafts are now working group drafts, but I didn't track whether there was some conditional, like, as to how they should progress. Yeah. I'm not actually suggesting anything. I have my suspicions that some people may like one solution a lot better than the other. And I don't know what the proportion is. And so there might be some people who say, why are we doing both? I don't know.
Greg, as chair, I think the suggestion Stig had was that each have a different use case, but we need to document in each one why this use case is unique and needs a separate mechanism. And that way, and reference the other doc. So at least that way, if someone's going somewhere and don't find what they need, they see this is another MTU solution for path as opposed to area. That sound reasonable for documentation purposes? Anyone following along? See that? Think that sounds reasonable? Or do you think these should be merged? Who thinks keeping them separate but referencing their use case and the other document is sufficient? Raise your hand. Who thinks that's not sufficient? All right. You think they should be put together? All right. Say minute taker. Show we have one vote for together and a half a dozen that showed merged, or excuse me, separate. So we'll take that to the list just for confirmation. But I think what we'll need is that text to confirm the text is clear, and then we'll take a vote from there. Oh, AD hat. Watch out.
Hi, Alvaro Rutana, AD. It would be great for me personally, maybe not for everyone else, if you progress both drafts together. They're going to both go through, so that when we get somewhere, we don't have to remember that 3 months ago some other draft that was similar went through, and all the questions to why are they not one, and all this stuff. So if they can go together, it would be great.
Thank you. The AD has spoken.
Yeah, let's catch it. Let's make sure it's caught up in the it's caught in the minutes. Okay, please.
Yeah.
Battery. Oh, we got a new battery now. Power button. We had the power button on before. It was flashing battery. Oh, then maybe they dropped it while I wasn't paying attention.
All right. Yeah, I just want
Battery.
to add that there are some pros and cons with both solutions, so we should make sure we have some text on that too, so people have some advice or idea which solution is suited and so on. Yeah. All right. So the other draft I'm presenting is the MLD draft. I don't have any slides for that. Nothing has happened to the draft for scroll IETFs, and I think we are ready for working group last call, or at least we need people to help review the document and give us some input on what to do with it.
So often calling last call brings those conversations to a head. So I think we are at that point if it's been kind of quiet. So who's read the MLDP draft? Was it MLD draft? It's MLD.
Yeah, I should add that nothing has changed for maybe
All right.
5 IETFs or something. So
Those read, who thinks it's ready for last call? All right. But the notes show the same readers said it was ready for call. So we'll take that to the list for a final vote and run.
okay, thanks.
Thanks, Stig. Let's put it back up. There we go. Next up, I believe, is that right? LSR Ethernet extension, yeah. So I think got a laser pointer, but we can't do the slides.
Hey all, good morning. This is Senthil from Huawei India. So I'm going to present the draft that we have written to advertise the Beer ETH NCAP capabilities via IGP. So let's get started. Slide please. Yeah, we all knew that Beer ETH is one of the encapsulation options to deploy Beer in non-MPLS Ethernet networks. So like Beer MPLS, Tracheo's software hardware upgrade. So the BFRs supporting Beer ETH NCAP must advertise this capability along with the other required parameters so that the other BFRs in the domain can learn it and then decide whether to include or exclude such a beer ETH capable node for the path. So this draft defines the required extensions to ISIS and OSPF to advertise the NCAP capability. Next slide, please. So how to advertise? Pretty straightforward. We can add a new sub TLV which can be carried within the beer subdomain TLV. Pretty much similar to MPLS and CAP. As you can see, it's possible that a beer subdomain may support more than one beer NCAP type. So in that case, the different NCAPs should share the same beer subdomain parameters like BFR ID, BAR, IP algorithms, and also the selection of encapsulation type to be used at the ingress node or by the transmit nodes at each hop is up to the local policy. So that's something which is outside the scope of our org. Next slide, please. So yeah, the presence of a TLV can identify whether the node is capable, I mean beer ETH capable or not. That's fine. So what exactly to advertise within the TLV? Let's have a look at beer MPLS and CAP. It's pretty much same that we are going to do here as well. The first thing is we should advertise the bit string length that's supported and for this NCAP. Number of sets supported for this bit string length, same as max SI in beer MPLS case, and BAFT ID for each set. I mean, like that's the only difference that we see, that in case of MPLS world, we used to advertise the labels. Here it will be 20-bit opaque BAFT ID. Next slide, please. So let's talk more about BAFT ID. RFC 8296 specifies that BAFT ID in non-MPLS networks is a domain-wide unique value and is not expected to change at each hops as the BFRs forward the packet. So do we think it's really required to advertise the BAFT ID? Because it's anyways a domain-wide unique value, it's not going to change at each hops. We do think that it's better to advertise the BAFT ID for two reasons. One is there are more than one possible ways to encode or generate the BAFT IDs, right? So for example, the draft non-MPLS BAFT encoding describes two possible methods. Particularly since there are more than one ways to generate and assign the BAFT IDs, it's better to advertise so that, just in case if there is a provisioning mistakes, we would be able to detect it automatically, and the nodes would be able to, let's say, exclude the node from the path, maybe raise an alarm. So that's one thing. The second thing is we think that the beer architecture can be maybe extended in future to support non-domain wide unique BAFT IDs as well. So in that case also it'd be nice to advertise the BAFT ID just like what we have done for MPLS. Next slide. So yeah, once we say that we have to advertise, let's see how, what's next. So in beer MPLS world, foreign subdomain and BSL pair, contiguous labels are allocated and we advertise only the base label, right? So this way we avoided signaling each labels, a label per set. Instead, we just used to advertise only the base labels, and eventually the signaling is simplified. Should the BAFT ID in non-MPLS networks be contiguous, similar to MPLS label? Not necessarily, but we think that just to make the IGP signaling simpler and to avoid having to advertise multiple TLVs advertising BAFT IDs for each set, we suggest to follow a similar approach. So allocate contiguous range of BAFT IDs, advertise only the base BAFT ID and the BAFT range. So that's what we are proposing. The existing two proposed BAFT encoding mechanisms by the other draft encodes the set identifier as the last 8 bits. So I guess they fits this rule. It's just that in future, if we are going to come up with new encoding schemes, we have to ensure that that's going to follow this. Next slide, please. So here we are. So this is the actual TLV that we are proposing. If you have a look at it, I think it's pretty much same as what we have for beer MPLS, just that the base label is replaced with BAFT ID. So I think this is straightforward. It's going to be carried under beer subdomain TLV. Next slide, please. Pretty much same for OSPF. Again, the only difference being the base MPLS label is being replaced with base BAFT ID. That's it from my side. So please do read the draft and let us know in case of any comments or inputs. We think that it's pretty straightforward that we must advertise. There's no questions about that, I guess. Maybe the only thing that we have to discuss and arrive consensus is about advertising of the BAFT ID, and is it okay to advertise the contiguous? Is it okay to force that we should allocate contiguous range of BAFT IDs, and is it enough to advertise only the base BAFT IDs?
Sorry, we are battery issues. Who's read the draft currently? Who thinks it's ready for working for adoption? All right, we got solid support. Who thinks it's not ready for adoption? I see no one. Okay, let the note show 0 for no. Pretty much room support for those who read. Let's take it to the list. Thank you.
Tony P. So one comment. I think the draft would benefit from addition of something that explains that the BIFT IDs in MPLS and this draft, the ETH are completely unrelated. So the same value does not mean it's the same BIFT ID. Because it's also completely symmetric, which is wonderful, but I think it's very easy to confuse, especially since you advertise them all in the same sub-TLVs, right? When the values repeat, to explain that those are completely different BIFT IDs and the same value may be used in both and means something completely different. Just one sentence, but I think it will prevent people from doing, pretty crazy stuff on the implementation.
Okay. Okay. Good morning, everybody. So I'm presenting this the BIER multicast overlay for HTTP response, and this is the current status of this draft. It is recently has been adopted. And in terms of what has been covered till now is just a quick recap. We have been with what it starts off from the realization of the use case that is in the BIER use cases document, a reference architecture, and the realization of the multicast overlay has been described over IPMC as well as BIER, and then we try to compare both. And then we go into a little bit details about the realization over BIER and add some operational details. If you go to the next slide. So again, this is the reference architecture that has been described there, which shows how this overlay can be achieved in terms of the functionalities that are shown in the red are the service handler function, typically on the BFER and BFIR. And there is also a PCE, which can be tied together with the BIER TE. Next slide, please. In terms of some of the details functioning with reference to the architecture is some of the deployment options has been described, how the service handler can be deployed along with BFER and BFIR. And it also includes a description that the work that has been done at DVV and BBF, and try to kind of, again, bring some comparison there. And also some operational procedures has been updated. Next slide, please. So in terms of the next steps, basically, we're trying to get some feedback as well as what we can do to extend or capture some of the details. So we thought of some other interesting use cases that kind of fits here, and those are listed, like something like a file replication in CDN. Another interesting use case is software updates using HTTP, which is very common, something related to OTAs, over-the-air updates, and also very futuristic. Recently, there has been a focus group in ITUT which describes Network 2030, where some of this work can be relevant or tied to that work there. And also in terms of adding certain details in terms of the service handler that has been deployed in BFIR and BFER, and there we think some details can be added in terms of how the path ID can be resolved to BR header, and also the PCE or the tie-in with the BRTE, like how the registration procedures can be done, and also the interface to the BRTE element. So these are some of the areas that can be the work can be extended. So just to get some input or feedback from the working group, whether anything else the working group can suggest, we can consider that to add. So it's basically open for your inputs and comments. Thank you.
Comments? There we go, Jeffrey. Thanks.
Jeffrey from Juniper. I'm a little bit confused. Do you use IP for all this at all, or do you not use IP?
So it is over. So we are taking the HTTP responses over the BIER. So that is basically, like we don't specify whether IP is used, or it's a typical way, that you will deploy BIER. So it is an overlay over BIER.
Overlay over BIER, but not necessarily IP.
Yeah, yeah. So.
Okay.
Any more questions? What's the status of the draft then? As it says, you said you got new use cases to add.
Yeah, so it has been. Yeah, so basically, we are open for inputs and feedbacks. So these are just some possible or areas that we can add some details.
Who's read the draft in its current form? Slow. Who finds these use cases something you can help contribute to, of interest? So this is Chep speaking just as chair and contributor. We're at a location right now. We've got a great infrastructure in place, and we're starting to see use cases come through. With the use cases draft is kind of expanded, kind of in limbo, but we're going to keep it open as we can add things to it. I'm a little hesitant to add use cases unless we've got operator support, like problems we're really trying to solve, instead of just like engineering for the sake of engineering. So I like them getting out there. Let's get those to the list and request some input. Okay. If we have some use case input that resonates with those to bring the solution to them, we'll document it. But I'm kind of hesitant to document for the sake of document. I think what we've got so far is a good use case to roll with. Mm-hmm. But anything add new, we need support to do.
Okay. So you suggest to ask for feedback in the list?
Absolutely. Let's bring this back on the list. I hesitate to say last call, but sometimes you got to do that to get people to wake up. Mm-hmm. And that's the part of the process anyway. So let's start with just bringing the thread back up, see where we go from there, if it's time to wrap it or to expand it. Okay. Does that make sense from the room? Nods? Okay, excellent. Thank you.
Thank you.
Go ahead and put it back up there. Yeah. All right. Mr. PIM signaling. Got MLB, Human.
So Human with Goalie Nokia. This is more of a trying to get feedback on the changes on the draft. We had some good conversations with Eric and Sleek, and we added a couple of paragraphs into the draft. So the main concern was that maybe we are not going to be able to grab all the information that is necessary through the beer header itself. So it could be useful to actually have a PIM join attribute added in the PIM signaling that specifies some of the beer information, like the beer prefix, the subdomain, the BFR ID, etc., etc. So we added 2 new attributes. The attribute types are TBD by INNA. But basically what these attributes do depend, regardless to whether it's IGP v4 or IGP v6, you can add this attribute to attributes to any of them, and they just advertise the beer information for IPv6 or IPv4 through the PIM signal. So basically, we just want to make sure we didn't get any comment back from the working group. I just want to make sure, and the other authors, that this is good with everybody. And if there are any other comments on this draft, anything else, Augustine? Okay, so next slide.
Any more?
Okay.
There we go.
So again, with regard to the solution, if there are no other comments, from our point of view, it's complete, and just wanted to take the next step forward. That's it.
Any more questions or comments? Who's read the draft in its current form? Excellent. I will say, just does reflect that a lot of the comments we had, I see co-authors now from the original comments, so it sounds like we've converged on something, which is great. Who thinks this draft is ready for last call? Yeah. So it doesn't mean it's ready to publish, right? Remember that. But if we think it's complete, it's time to branch this out beyond the working group, get more input. So, all right, so let the note show that we had the readers one on the call. Time to take it to the list. You got a comment? Oh, look at 5 hands out of. Well, no, they weren't readers. All right. Tony has to speak every once in a while, so we know he's awake. So, all right, you've got the next one too. Lumen? Yeah, you're back to back. Yeah. Try to make it easy. Try to. The agenda shifted a lot this morning as new stuff was coming in and read. But you ready for this one or not?
Yeah, I don't think I wanted to present this. I think there was some great, again, conversation between myself, Jeffrey, and ICE. So we're going to get back together, brainstorm it again, and come up with an alternative solution. I think that was the conclusion. Am I right, guys? Or? Okay, perfect.
Good. That's a good status update. Thank you.
Okay.
All right. Down. Backwards.
This is Nagendra from Cisco. Yeah, so this draft is about OSPF V3 extension to carry beer information. So I'm sure you'll be aware that RFC 8444 defines the extension for OSPF V2. It went under rigorous review, and this one basically inherits all those TLVs and defines how it can be carried in the relevant OSPF V3 extended LSAs. The flooding scope and other machineries, they are almost similar to OSPF V2, except the LSAs, the extended LSAs where the sub TLVs and TLVs will be carried, is different for OSPF V3. So this is the sub TLV that will be carried in intra and inter-area prefix TLVs. Again, like I said, this is not much different from what we defined for OSPF V2. And this is the sub TLV that will be carried in beer sub TLV. Okay, so the authors believe that this is pretty stable. So the next step, I would like to get some comments, or if it is ready for workgroup adoption.
I just have sorry, my own little brain part here. Did the original OSPF v2 draft originated here, but didn't it finish up in the other working group? It did come out of here? Okay, that makes sense. Yeah, I mean, we fought back and forth about where it belongs. I thought the work did, but we finished here. Excellent. All right, so it would make sense to adopt it here as well. Who's read the draft? All right, who thinks it's ready for adoption? Yeah, same set of hands. Okay, we'll take that to the list. Let the notes reflect that we had a win. It's just a win or lose. We don't take the numbers here. Oh, Tony didn't read it. Just want to throw that out. It didn't. It just showed up this morning. Give me some. Yeah. Well, at least, who's here from Cisco right now? Just curious. Have you migrated to 365? Do you know you can't edit your PowerPoint if you're not on the VPN? Yeah, my license got pulled, and then suddenly this morning, right. So I had a lot of things fighting us today. Excellent. Thank you. We'll take the list.
Hello.
So, yeah, I don't know.
Okay. Can you hear me?
Just get your wrap up.
Okay. Hello, working group. This presentation is about BeerFast reroute. Next slide, please. This is a new draft. So, what is the problem that we consider? The BEER is an overlay routing that depends on the routing underlay. The BIFT entries are derived from forwarding entries in the routing underlay, and in case of a failure, a BEER subtree may be disconnected with all the consequences for the affected traffic. And the BEER traffic will be delivered again only after fast reroute in the routing underlay has happened, after reconvergence of the routing underlay has happened, and after the BIFT entries are reconfigured. And this may take time. Okay, we need to distinguish link failures and node failures. Link failures may be protected by lower layer technologies like MPLS and MPLS fast reroute, but a counterexample to that could be a simple Ethernet deployment without any resilience mechanisms on the layer 2. Another case are node failures. They cannot be protected per se by the lower layer technology because there are failed nodes that replicate traffic, and this knowledge is not available in the lower layer technology. So in case of a node failure, lower layer resilience mechanisms do not help. We propose BeerFast reroute as a solution. Bit forwarding routers detect unreachable next hops that may be performed with the help of BFDs, and the BFR then becomes a point of local repair. That means the PLR takes actions for link or node protection. And as a consequence, affected BEER traffic is then delivered as soon as the routing and underlay works again. For instance, if we have fast reroute mechanism in the routing underlay, this can be really, really quick, or at the latest, after reconvergence of the routing underlay, then the BEER traffic should be forwarded again, even before the BIFT entries are reconfigured. Next slide, please. So, BeerFast reroute link protection. BeerFast reroute has two modes. One mode is link protection, and the other mode is node protection. Link protection is really simple, but it protects only against link failures. So how does it work? Basically, the PLR just tunnels BEER packets through the routing underlay to the next hop if a failure is detected. And then the packets arrive as soon as the routing underlay delivers packets again. And this works also with for instance, with IP fast reroute. Why does it work? Or why is this a protection? The tunneling deviates the BEER packets to another interface that is still up, so that packets are no longer transmitted over the failed interface. Next slide. Okay, this is about node protection. Node protection is more complicated and requires a more sophisticated mechanism. It protects against link and node failures. If the primary next hop is not reachable, the PLR uses a backup FBM, a forwarding bit mask, and applies it to the beer packets before transmission to avoid duplicates. So we cannot just use the normal FBM, we need to have backup FBMs. And the traffic is not sent to the normal next hop, it is sent to a backup next hop. And also this traffic must be tunneled through the routing underlay to these backup next hops to bypass the failed component. So we have the backup FBM and the backup next hop. And these are backup entries that require some space somewhere in the BIFT so that an extension would be required. How are these backup entries computed? That depends on the destination that we want to protect. If the protected buffer is the primary next hop, the backup next hop is again the primary next hop. So this is not a different node. But we need to change the forwarding bit mask. This is a bit mask with only one bit set for the primary next hop that has failed. Why do we send traffic to the primary next hop that has failed? Well, we do not know whether it's a node failure or a link failure. And for that, we need to send the traffic to the next hop too. But this next hop should not forward this traffic any further to avoid duplicates. How is it with other bit forwarding egress routers that we want to protect? Well, the backup next hop in this case is a next hop on the way to that specific bit forwarding egress router. And the forwarding bit mask contains all bit forwarding egress routers in the subtree that goes through the PLR and through the primary next hop and the next hop. So we need to consider the specific part of the wildcast subtree. Next slide, please. I skipped this. This is an example how it works. This one again. And here's the summary. So we propose BeerFast reroute with two different modes. A simple mode that protects only link failures, and a more sophisticated mode that also protects node failures. The link failure mode, or the link protection mode, tunnels beer packets through the routing underlay to the next hop and does not require any header modifications. So this is really simple and does not require any extensions to the BIFT. With node protection, this is different. It protects against single link and single node failures. It tunnels the packets through the routing underlay to the next hop or to next hops, and requires header modifications to avoid duplicates. This mechanism requires an extension to the BIFT to store backup forwarding bit masks and backup next hops. We have a working prototype that implements Beer and BeerFast reroute based on P4 technology. This is a new draft, and I think it requires discussion by the working group, and we certainly also need some more input to progress this draft. Thank you.
Can you go back to the problem statement?
Name.
Slide. Name, Jeffrey, John, Juniper.
Affiliation.
I beat you. Okay. So at the top, you mentioned that beer traffic delivery again after FR in routing underlay, after convergence, reconvergence of the routing underlay. At the bottom, you also say effective beer traffic delivered as soon as the routing underlay works again. So what's the difference?
Well, in case of a in case of a failure, a link is down or a node is down, and then the routing underlay needs to be repaired. If you have a fast reroute mechanism, then any traffic is forwarded over the fast reroute, while the normal forwarding entries are still old and do not work because you use the fallback solution. And after a while, the normal forwarding entries are repaired, reconvergence has happened, and the BIF is recomputed.
Well, the BIF entries they can include the backup entry path as well. So basically, the very advantage of BIER itself is that you can reuse existing underlay reconvergence mechanisms. So
right.
That's all you need. We don't need to do anything special for BIER to take advantage of that. You do not need protocol extensions. You do not. All you need is your implementation. That you when you construct the BIF table, you already include the backup path information that is already available from the unicast protection mechanism. So I'm not sure why we need this document here. And also, when you say you need BIF extension, do you mean the extension to the protocol, or do you mean the additional? Your internal implementation includes some additional work to do for protection purpose.
I mean additional fields in the BIF. That means some place to accommodate the backup entries. And,
Okay.
as I said, in the problem statement, we have to consider link failures and node failures. Link failures are easy because we can just reuse alternative paths or whatever. But this is different with node failures because the knowledge about replication has gone if the node has failed, and that needs to be repaired by some mechanism.
But there are a lot of details. Maybe we can talk offline. But my understanding is that the unicast node protection mechanism can be reused here again. So nothing special needed here. That's my understanding.
Mm-hmm.
Hi, Cisco. So after a failure, you're rewriting the bit mask, right, to reroute the packet.
Right.
I think that only works with BIER-TE.
Nope.
I think so, because with normal BIER, your bits are your endpoints. And if you're going to say my packet needs to go via this node and that node, you need BIER-TE forwarding. I don't see any other way how to do that.
The trick is that you reuse the routing underlay after it works again. For instance, you can use the fast reroute mechanism in the routing underlay or the reconvergence, and then the traffic bypassed the node before BIFs are updated.
But if the BIER underlay, if the underlay got changed and your BIP positions are reachable through another path, that's normal convergence, and then your bit mask doesn't need to change.
The bit mask needs to change because you forward traffic to several next hops.
That's BIER-TE.
Hmm?
That's BIER-TE specifically. This is Greg Shep from Cisco, but what ICE is pointing out is the intermediate BIER routers don't have BFIDs in BIER. So there's no way to enumerate a mask to send you going to that next hop. In BIER, only the endpoints have bit positions. So if you're trying to use a bit rewrite to get to a given node on the way to a path, that's BIER-TE. That's not just BIER.
Okay, I see. There we need. Maybe there is a point that we need to solve that.
Okay.
Yeah, because that was mildly excited to see something to native BIER, but I think this applies only to BIER-TE, which limits the scope, I think.
Yeah, understood.
Human with Golden Nokia. Yeah, I think I kind of wanted to echo what ICE was saying. On the way from recovery, from failure recovery, I can see fast reroute, but on the way back, usually in fast reroute, you do like a make before break.
Can you say again, please?
Usually in fast reroute, you can do a make before break. But here you're using for the going back from fast reroute to the original path, you're using the underlay IGP, from what I'm understanding, right?
Right.
So again, I guess the part I'm kind of trying to get my head around is that if on the way back you're using IGP, why not for going for the protection use IGP too? Like I think IGP is just the underlay IGP gonna take care of everything.
Yeah. Well, in fact, we use the IGP for protection, but we use it before the BIFT entries have been updated. So imagine a node that the next hop fails, so all the information about packet replication has gone, and this needs to be protected. So we use so we basically redistribute the traffic to all the next hops or the relevant next hops, so that as soon as the underlying IGP works, the traffic can be forwarded without the need for the recovery of the redistribution knowledge of the next hop, because it's contained in the PLR.
Maybe I can put it in a simpler way. So to detect a failure, it's two-way BFT.
Say again?
Is this one working? No? I mean, yeah. To detect a failure, it's two-way.
Yeah.
There is BFT,
right?
Or you detect the port, the fiber goes down, right? So if your BFT or your fiber, the interface is connected to the IGP, that IGP detection gonna really kick into the beer, and is gonna give you the brand new BFR ID that you need to go to. So it is really relying on the IGP failure. I just cannot see like how is a fast reroute here gonna make it happen any faster. I don't know, maybe I'm missing something.
Well, you need to propagate the information. First of all, you need to propagate the information into the BIFT in the beer routing tables, and second, you need to reorganize the beer distribution trees, and this will certainly take some time.
If I can interject again, that specifically is beer TE. So it sounds like the draft needs to be rewritten in a way that separates the concepts entirely and understands that we can't specify a next hop with a beer bit in beer.
Yep.
That's beer TE.
I also have an answer to this question. We do not need to have to reroute traffic to a bit forwarding egress router. It is sufficient to address the next
How do you address it?
Router.
How do you address it?
IP address, because you leverage the routing underlay anyway. Yep. Right.
And isn't that the IGP doing that for you? I mean, that's what part of the...
Yes, the IGP does it for us, and we use that. But when the IGP is able to do it, the next hop or the knowledge about the packet replication is in the next hop, and this information needs to be reorganized.
That's what the IGP is doing.
No, the IGP does not mess with the FBMs, and it's important to adapt the FBMs.
The IGP is just using topology information. If the topology changes, it gets updated, and the beer fib is built on those updates. So the layers stay consistent. There's no missing information there.
The time, yeah.
So maybe one confusion here is that like when you talk about protocols like RSVPTE or even LDP, that's signaling. So the signaling needs to set up a fast reroute path. If there's a failure, it takes for the signaling some time to reconverge. With beer, since it's just following IGP and all the information is coming from IGP, really the detection is IGP. So with the same token, so that's one point. And the other point is that I think as a working group, we really need to understand whether we need to make some kind of improvement here with regard to beer failure detection time. As of now, like from our implementation point of view, we don't see when IGP fails, we just, pretty fast, we detect that and we converge. But as a working group, we need to understand whether we need such a mechanism, and if so, what is that mechanism, whatever it is, right?
Yeah.
So let's take the comments first.
It certainly depends on the timing. If the BIFT is updated really quick after the IGP has been has converged, if it's only 5 milliseconds or so, then there is certainly not a need for a fast reroute solution. However, in IP networks, we have the fast reroute to speed up the to be faster than the IGP reconvergence. And therefore, I expect that also such a mechanism makes sense on the beer layer.
Yeah.
Rajiv Asari, Cisco. So the typical challenge with any tunneling-based FRR solution is that it usually increases the amount of traffic flowing on a given link that is used to send that so-called backup traffic. If there's already the same amount of traffic going to another set of recipients, that would be completely oblivious, right? So this is a very common problem that had existed with the RSVP-TE since inception. So depending on how you're defining those tunnels, you may have to be careful about this disadvantage that if you're, for example, if you're using unicast to hop over the traffic towards NN hop, you're simply duplicating or triplicating or quadrupling the amount of traffic going on that backup link at that point of time until the network converges. So something to note. And the second, then we already have BRTE FRR draft. So what's different in here?
Okay, what's the difference? For the BRTE FRR, we leverage BRTE for tunneling the packets to the backup next hops. Here, we use the IGP, the routing underlay for tunneling. That's a major difference. And with BRTE fast reroute, we can explicitly indicate the backup path. That's not possible in a mere beer environment, and that's why we need to leverage the IGP when it works again.
Okay, thank you.
Jeffrey Don Juniper again. Does this require any protocol extension?
I'm not sure. Of course, you can just do it in the implementation because it's a local mechanism, and therefore it does not require signaling.
Okay, right. So yeah, that's what I thought. So basically, with existing beer architecture and all the IG underlay mechanisms, my belief is that a particular implementation is already able to do beer fast reroutes. This is really implementation detail and does not require standardization. And maybe some operators or maybe some vendors may prefer this implementation detail. I mean, so that they have some competitive advantages.
What I can imagine is that when you do the tunneling stuff, then you increase the payload, and we can run into MTU issues, and possibly that needs to be possibly there needs to be a solution. Namely, otherwise, if you reroute the traffic, you have larger packets, then all the packets will be dropped. So then fast reroute wouldn't work either. So we need to think about that so that this mechanism can work.
Just in Abstro, a few comments. So I think we all agree it's BRT. You do need additional piece of information. Number two, when we talk about IP fast reroute, we mean it doesn't rely on a GP convergence. It means that you could pre-compute backups a priori and usually re-instantiate them in hardware. So you rely on either loss of signal interface down to switch traffic within milliseconds. You don't wait for a GP to converge.
Right.
And since it doesn't require any extensions and you want to talk about I don't know, architecture for alternative fast route, you might consider routing working group to talk about architectural things.
Say again?
Routing working group.
Okay.
This is where usually fast route work is happening. I'm the chair of routing groups, half official statement.
Okay. Stigmanas. Yeah, I just want to comment on the MTU part. So, so that's one of the issues I see with the path MTU discovery is that if you suddenly reroute through some tunnel, your MTU will go down, and it will take some time if you do probing until you realize that the MTU has gone down. So you might get packet drops, and I think that's one of the use cases. One of the reasons that I've been, presenting or talking about this other MTU solution. The issue though is if with at least my proposal is that you will always use the lower MTU that allows for the tunnel to be used.
Okay, so thanks for all these questions and the input, and I'm happy to take questions afterwards.
Okay, so quick summary from my side. So I completely agree with Ice, Human, Jeffrey, who else? Jeff. I was thinking about the control-based solution, right? When the controller is programming all the beer stuff, and I also don't see the need, because if you program it, you still basically program unicast next hop protection. Silicon kicks in on the BFD, right, with the FRR. And if you have LFA, you don't need tunnels. The moment you go RLFA, TLFA, I mean, IGP solved all the problems that kicks in. So it may be educational, just, a couple of napkins in the bar and walk through the stuff with the author.
But what you cannot do with such a mechanism is the packet replication, because you need to, when you want to fix the node failure, then a node has gone down that replicates traffic, and then you need to reorganize the
RLFA does it for you. It tunnels over it already, and you have it already on the fast path, and it kicks over. Magic works.
Okay.
And transparent to beer.
Okay.
Thanks. One of these downloaded instead it came up. I'll make sure it didn't.
Hi, I'm Zan from DTE. Today I will introduce BGP link state extensions for beer. Next, yeah, introduction and motivation. This document specifies extension to the BGP link state address family in order to advertise beer specific. For BGP LS extensions for beer, there are two extensions. The first is extended a new prefix attribute TLV for distributing beer information. The second is it's beer MPS encapsulation sub-TLV is defined for advertising MPS specific information used for beer. Okay, next is the update. In this version, we update the beer TLV, add BAR and IPA fields. For beer MPS encapsulation sub-TLV, we change the label range size to max SI. Next, please. Yes. Next step, comments welcome and seeking for working group last call. Yeah.
Who's read the draft? Who thinks it's ready for last call? Okay, at least it would start some conversation. That's great. So let the notes respond that the vote was for last call. We'll take it to the list to confirm. Go from there. That was easy. Really? No other comments?
Okay.
Thank you.
Yeah. Yeah. That's why. Yeah. 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 This is the draft about for PCE. extensions for beer. Yes. This document specifies extensions to the PCE that allow a PCE to compute and initiate the path for the beer TE. Yes. There are mainly 4 extensions in our draft. The first is beer capability advertisement. We defined a new path setup type for beer. And second, we defined the beer TE PCE capability subtool to extend beer capability. The second is we extend the RP and SRP object and defined a new path setup type for beer TE. The third is endpoint object. There are 2 options. One is reuses the P2MP endpoint object body for IPv6 and IPv4, which is defined in FC 8306. And the other option is we define a new beer endpoint object to carry the BFR ID information. The last is YAO object. We define beer YAO sub-object to carry adjacencies, bit strings, BSL, subdomain, and SI. Next, please. Yes, this is the details extensions. First, beer capability advertisement. Yes, this is we defined a new PSD type. It means passage setup using beer TE. Yes, the second is we defined a new beer TE PCE capability subtool. This is the format. Next, please. Yes, this is the RP SRP object. We define PST, a new PST type, which means passage setup using beer TE. Yes. This is the endpoints object for specifying the beer information of the path for which path computations is required. Endpoints object is required. Yes, there are 2 options. Reuse the P2MP endpoint object body for IPv4 and IPv6, which is defined in FC 8306. Optionally, we defined a new endpoint object for BFR ID. The format is as follows. It contains leaf type, shows BFR ID, and 1 or more destination BFR ID. Yes, this is YAO object. For carrying beer TE path, a new beer YAO sub-object is required. It mainly contains BSL subdomain ID, SI, or adjacency bit strings. The max value of BSI is limited to the 1024 bits in case the beer YAO sub-object is too long, because the YAO object, which is defined in FC 8306, the length is 8 bits. So we limited the BSL to the 1024 bits. Yes.
Let's take questions.
Justin, sir. So, generic question, why are you presenting it here? It definitely belongs in PC, and I'm not going to provide PC-related comments now, but it just doesn't belong here. It's so deep into PCAP semantics, I don't think.
Yeah. We also,
the previous draft, it should be subject to IDR rules, to implementations, whatnot. So, again, I don't think it should be here.
Just Greg as chair, I think it's fine to present here. If the request
For
is
your
for document-
information is fine.
Correct.
It shouldn't go through.
Is it also being presented in PCE?
yeah.
It is.
Yeah.
All right.
Okay.
Very good. Thanks.
Tony P again. So, grade necessary, I think it's missing a significant component. We have the Yang models, and we were discussing whether the beard and the BIFT mask should be programmable, right? Sandy, you remember discussion, right? And I think that is also needed in the PCE, right? Because when you have a controller model with the PCE, you want to program the BIFTs and the beards, right? Not only the TE. And this work needs to be synchronized with the Yang models very closely. So I'm not convinced that actually that should be exclusive in the PCE working group, you know, where we may just run off the rails and do something else that we're doing with the Yang model here. Well, sorry, but it is important that this work stays synchronized. I mean, in which framework, I don't care, but both Yang drafts and this has to basically present the same model, right? Architectural model of beer. Yeah.
Any other comments? All right. So I trust you're working closely with Sandy on the Yang overlap. We'll be presenting in PCE as well, which is great. Is your intent to adopt there and just informational here, just for feedback? Yeah. So, okay. Excellent. Yeah. You're not the PCE chair, right? You're PCE. Oh, okay. We have a PCE chair here. Excellent. All right. Can we sync after? All right. Thanks. Yep.
Yes. Next step, comments welcome. Yes.
Yeah. Any more? Oh, we have.
Hi, Cisco. So maybe I'm going back to Michael's stuff a little bit here as well. So I think this is good, let's say, for BTE. It's a great way, to advertise those big positions and put those tables in place. But I think the key point with BTE is that there is no underlay, there's no IGP. You don't need it, right? And this is sort of a replacement to put those bits there by the controller. So if you want to do fuzzy route then, and you don't have the underlay, then Michael's stuff might.
Well, the PC allows you for a low touch and a high touch, right? You can just touch the edges and rely on on the edge of things kick in, right?
So let's say you can use PC also for normal beer stuff too, right? But I think this was particularly targeted for BTE only.
Yeah.
And that was precisely my comment, right? That the generic beer would benefit from precisely the same things as well. We have to synchronize all this stuff with the Yang, right?
Yeah.
Yeah. The Yang did model for beer. Yes. What's about the latest version? At the Ethernet at IPv6 encapsulation type, change the IGP type to underlay protocol type to allow BGP. Add IPA and BAR in the subdomain, and change the beer MPLS label range size to max SI. Okay, next please. Yes, this is the data config tree structure. We augment RT routing with beer containers. It includes encapsulation type, BSL, BFR ID, BFR prefix, and some parameters with the subdomain. Yes. Next, please. Control plane. Yes. Right now, with it supports the ESIS and OSPF as control plane. Yeah. Next, please. Yeah. Operational state. It includes encapsulation type, BSL, BFR ID, BFR prefix, and some parameters with the subdomain. It also contains the beer index routing table. Yes, next notification. It contains BFR ID collision, BFR 0, and subdomain ID collision. Yes. Next step, comments welcome and seeking for working group last call.
Okay, so I'm paying attention here because that's important. Sandy, great, you hear. I think we need a profound discussion on the working group list. I don't know, Barbov, something, whether the beards, so first the BIFTs didn't get added. Do they belong in the Yang model? I do think so. And then the discussion is necessary, you remember, Sandy, whether the beards and the BIFTs are writable or read-only, because that has a profound implication how you can deploy beer using, you know, any kind of a controller or no IGP architecture. And that will be a very significant, you know, fork in the road we'll be taking, right? So I don't think this is ready for last call at all. This work is necessary, must be concluded, but we need to take this fork and then along this path fill in the voids, okay?
Hi, Senthil from Huawei. I think you mentioned that you've added IPv6 NCAP type. Yeah, it's curious to understand, are you talking about a new BRv6 NCAP, or are you talking about using MPLS NCAP using in the IPv6 underlay?
I think it contains IPv6 and the MPI source, both.
I see.
Yeah, both.
Sandy, can you open the mic? Thanks.
Sandy Zhang, ZTE. I just want to answer.
Stay to the mic. Stay to the mic.
Yes, we also include many encapsulation types in this model. So MPLS and non-MPLS is also included in the Yang model. So Ethernet is also in it.
Right, but the question specifically was about which B6 and cap type is referenced in the Yang model.
Because we have beer in 6, we have other stuff being proposed, right? There's a couple of flying things.
That aren't working group docs currently.
Yeah, I mean, like the question came because we've added the NCAP type, but I could not see the the other configuration parameters getting added for Ethernet or IPv6. I could only see the MPLS label stuffs under both IPv4 ports and IPv6 ports, and that's the reason why I asked this question.
So do you mean what's the difference between it?
Here we can see that under the address family IPv4 and IPv6, you're only talking about the MPLS stuff. So BAFT IDs for Ethernet or IPv6
yes.
and those things were not.
We can add Ethernet type to find this. Yeah. Okay. I think that means that the question is why we only define MPLS label base in this part. Okay.
So anything delivered in IETF today has to be NMDA compliant.
Yes, we implemented it, but we have not verified the non-MPLS part. Yes, MPLS part has been verified. So, oh no, we are
expand the acronyms. That would help.
compliant, right?
Okay, please to the mic, guys. We need minutes. We need the stuff on the mic. Yes.
Jeff Tensor Abstract. So
Come on,
IETF
you're a
published an
chair.
RFC, right? Expanding on a new architecture for data stores, and the guideline is that any Yang model defined today has to be compliant to this architecture. That's all. So you don't have two trees, one for state, one for configuration. That's this point.
NMDA compliant. Yes, we can discuss if some leaf can be read or write or read only, right? So, but this model is NMDA compliant. But I think we can discuss if some leaf will be read only or something. We write it. It's NMDA.
Short comment to Tony situation. Answer is yes. any piece of derived data should be in here. We don't use YANC to only configure things. We also use YANC to monitor things. All the telemetry today is model driven, so yes.
It sounds like there's some more work within the list. So we can turn it up. I mean, honestly, asking for a last call causes this conversation, but I think we need the conversation is triggered before then. So can you put in the notes that further working group interactions input is required? Thanks.
No. Thank you. Good morning. I'm Sandy Zhang from ZTE. This presentation is for BRT Yang. This Yang model is designed according to draft IETF BRT architecture. And in the model, we defined the BRT configuration and operation. Let's see its key features of BRTE. From it, we know that BRTE is based by controller. And so the BRT forwarding table is readable and writable. It's not same with the other protocol. And the forwarding table is based on agency. Let's see the overview of this Yang model. In this Yang model, we include agency BP configurations and forwarding items and optional TFR forwarding items. This is the overview of this model, 3 parts in it. And this is the detail of agency BP. From that, we know BRT controller can check the BFR typology and assigns bit operation to agencies. So, and the T agency type describes the character of the link. This is a big type for it. Thank you. It's the detail of this model. Because bit operation is multi-semantic in different subdomain and set identifier. So we implement the BRTE forwarding is still according to the combination of subdomain, bit string length, and set identifier. And the ECMP and FR can also be used in BRT forwarding. It's the detail of the forwarding table. From it, we know that we still define the TBIFTID in this forwarding table because we'd like to locate the forwarding items quickly. And this is the forwarding detail of the table. And we also defined the DNR flag in this model. And this is the out interface information about it. It includes the outer BFTID and the other information, the outer interface. And also we can use ECMP function in this table. So we defined the ECMP outer interface list and the according BFTID for it. And it's the FR table. This BRT FR is from the BRT draft years ago. So because we find that we can use some general paths for BRT path protection. So we remove that part from the specifically items outside. So we can use some general paths for BRT protection. So it's the detail of the table. Next. it's notification and RPC. For now, we defined the notification for the invalid of the beer of link is set to 0 situation. And in future, we may add some other notification or the potential RPC for it. The BRT YAM model has been used in Open Daylight project. So this YAM model has been implemented, and this project has been released in nitrogen version. You can find the more information about it through this link. So this model has been verified, and it's feasible and practicable. It's the second time for this YAM model presentation. Last time is on IETF meeting, Argentina meeting. So after the implementation, we think that this model has been ready for working group adoption. So any comments?
Any comments? So this is Shep as chair. I would say I believe when that draft was first submitted, TE wasn't even accepted as a working group item yet, right here, TE. So now that it is a working group item, this probably makes more sense. Who has read the draft in its current form? All right, who thinks it's ready for adoption? All right, excellent. Let the vote show the room supports, and we'll take it to the list. Thank you, Sandy.
Thank you.
Okay, everyone, I'm Chuan Shong from ZTE. My presentation today is the beer BFD. The draft has been presented and discussed in the mailing list for several times. We have updated to the third version. The update from last version, there are mainly 2 points update. The first one, we carry the BFD discriminator TLV in beer OM TLV to bootstrap the beer BFD in data play. And in control play, we extend the IGP protocol to bootstrap the beer BFD. And this is the comment from the last meeting. So let's slide. So let's overview the beer BFD. First of all, the beer BFD is based on the multi-point BFD draft. We use the demand mode divided in RVC 5880. And the beer BFD encapsulation used the beer OM pin format. We defined a new message type to set to the beer BFD. And then the beer BFD control packet defined in RFC 5880 immediately follows the beer OM header. And then the beer BFD session established, we provide 2 optional solutions to do the bootstrapping. The first one is the beer OM pin bootstrapping in the data plane, and the second is the IGP protocol bootstrapping. We use the IGP advertisement. And then finally, the BFERs use the source address and my discriminator to demultiplex the BFD sessions, including the BFIR ID and the beer MPS label for MPS network, and the BFIR ID and BIFD ID for long MPS network. So last slide. So the detailed bootstrapping, we provide several options as mentioned last slide. The first one is the multi-hop bootstrapping. We use beer OM ping echo request message, and then we follows that we carry the BFD discriminator TLV, which contains the local discriminator generated by BFIR for this session. Then we add a new section to do the IGP protocol bootstrapping. We use the ISAS and OSPF capability advertisement. we extend the beer BFD sub TLV. This is a new tier sub TLV which contains the local discriminator generated by the BFIR for this session and the related BFER's information. Then, based on the comments in the mailing list proposed by Sandy, we will provide the beer overlay bootstrapping solution, and it is to be added. So last slide. We summarize the beer BFD session establishment. The first step, the session of the BFIR is administratively created for a multi-point path. Then the BFIR will assign a unique discriminator. The session type is set to multi-point head. The BFIR will set to active role, demand mode, and the state is up. Then the BFIR should bootstrap the beer BFD to the BFERs and let the BFERs to discover the beer BFD discriminator. The bootstrapping solutions, as mentioned last slide, there are two optional solutions provided, the beer pin or the IGP advertisement. Then the BFIR will send a beer BFD control packet to the set of BFERs, and the BFERs will create dynamically created the session in the BFERs. The session type is multi-point tail, and will be set to passive role, asynchronous mode. Then this will finish the whole beer BFD session establishment. So we summarize the extension from the beer specific networks. We define the BFD discriminator TLV and the beer BFD sub TLV as the figure shown. So last slide. So about the beer BFD, we will do the further work. The first one, as I mentioned, we will add the beer overlay extensions for beer BFD bootstrapping, and maybe we will adjust the version or based on the update of the P2MP BFD. So that's all. Comments and discussion is welcome. Thank you.
Nokia. I just have a general question, and maybe I missed that. With the point-to-multipoint BFD for beer, again, I do apologize, maybe it's a dumb question. What are we trying to solve here?
P2MP BFD is not adapted to solve the beer BFD. The beer BFD will make some extensions to P2MP BFD, like the bootstrapping and the control packet encapsulation. So we defined some extensions based on the P2MP BFD.
Yeah, so again, I'm trying to get my head around that. Like for MPLS, I can see the point of it because there is a root and certain leaves, and those leaves are not predetermined. So like when you try to do a point-to-multipoint BFD for MPLS, you just go to a certain leaves, not all the leaves that are, all the PEs that are in the network. With beer, there is necessarily no tunnel, right? When the packet comes in, then you, based on the interested outgoing routers, you put the bits on top of the beer header and you shoot it through. So if there's no deterministic root and leaf, I don't know, maybe I'm missing something, but like I'm not seeing what this specifically will solve in the beer domain. Right,
Mike,
like
please.
IGP,
Mike, please.
I think like IGP is taking care of all this stuff. It's all
Stanley Zhang from ZTE. I'd like to answer Holman's question. Oh, sorry.
My close.
Because we'd like to provide some extension for beer egress or ingress router monitoring. So it can be used for multiple multicast source protection or any other function. So we want the beer BFD draft is like to provide the function of the egress or edge routers monitoring. So we think it can be used in beer environment, like VPN fail over the environment. So.
Jeffrey Dong from Juniper. I also had the same question. In fact, I know that the one of the stated use cases for the live protection, so that the egress piece can switch to a different source. But I also had comments there in different drafts. With beer, you don't really need that. But I'll table that for now. My real comment here is about when you use IGP to bootstrap. You mentioned that you would. Can we go back to the previous slide? Next slide. Next previous. Yeah, the IGP bootstrapping, I think you mentioned that you use the capability advertisements. Why don't you just use the beer information sub-TLV itself? Add that news sub-TLV in that beer information sub-TLV.
We need to use the to carry the bitstream information in the IGP extension. But in beer in the data plane, we will use the beer OM, and it has carry the beer header. So we don't need to use to carry the bitstream information. But in IGP, we will need to carry the bitstream information in the TLV.
Okay, I guess I missed the point of carrying the bitstream there. But let me do more reading and thinking there.
Thank you.
Jeffrey's point is good because we can use the sub-TLV defined also in beer.
Louder,
Sorry,
please. Name and affiliation. You know, you are all going pretty fast. The minutes have to keep up. So please, name, affiliation, structure the stuff, and no open discussion outside of the mic, please.
Stanley Zhang, ZTE. I'd like to answer the question from Jeffrey. It's a good point because we can define a new sub-TLV in the existed beer extension in IGP for define it. So. I think it's good. We can modify it later, right?
Human with COVID Nokia again. So just to ensure that I didn't miss anything, this is OEM over beer. It's not OEM over MPLS, upstream assign MPLS, and then beer, right?
It's the second.
It's the second as in?
The normal BFD over MPLS or whatever, yes. Multi-hop BFD.
Oh, okay. Okay. All right, thanks.
All right, so let me maybe chime in. So, I mean, I'm sympathetic to the use case. I think there is a case for multi-hop BFD. I'd rather have it done in the beer OEM, for which we have framework natively, but I understand BFD is around and, you know, popular and so on. When I looked at the draft, it is kind of a, so Greg wisely, he's not here, but I'll corner him. It looks like a mixture between the multi-point BFD, which is not an adopted draft, okay, it's still under discussion, and seamless BFD. Are you, I mean, Greg must be aware of SBFD. The whole work has been done. So this discriminator is not well described. If this is a global discriminator, BFD discriminator, this is literally SBFD, for which OSPF extension signaling and so on already exists. If it's not, I simply don't understand how it works. So I will corner Greg, but it looks to me like this is SBFD, you know, multi-hop, and the multi-point thing is until the draft gets adopted in the BFD working group, it's not even viable to adopt it here. I know was a little bit too a lot, but a corner Greg. Architecturally, I don't understand what this is either, Human. So I mean, I fully commiserate with you. I read it from 3 different parts. I was asking what's the architecture here, and I couldn't figure it out.
Okay, good point. We can add some seamless BFD contents on it. We can consider of it.
Right. So if there's SBFD, the full signaling, everything exists already. Right. But then we need the profound discussion whether this is the direction we want to go, because it preconditions a global discriminator on the whole network.
Yes.
Right. Which is its own operational model. Okay.
Thank you.
More comments? All right. Good discussion. Let's keep it up on the list. So, you got more on this? We're done, right? You were here.
Okay, thank you.
There it is. All right. So, housekeeping really fast. We have 2 sessions here back to back, split by a break. We got 20 minutes before the next one. There's basically 2 pieces of content left: problem statement and cap solutions with the V6 request. Then we've got Torless with TE, who wasn't supposed to come till later. Do we break up that conversation into 2 pieces around the break? Do we run right through the break? Do we jump into TE now and leave the V6 discussion for after? Who wants to go straight through the break? Want to go straight through the break? Who does not want to go straight through the break and needs something here? Yeah, the old guys. So, can we do the TE then first so we don't break the V6 discussion up, or do you guys don't mind? We can do all of your stuff now and we come back for TE. Well, that's what I thought. We put in after the session and we got time to go on. We're not trying to cut you off for Torless. Who promises to come back? I will be here. I promise you that. Okay. So let's go to Torless's TE discuss, and we have time before the break. We can get into 6 then. All right. Is Torless still here? Or did he run away? Oh, he is still here. I tried to scare him off. It didn't work. Hey, Torless, your T-shirt is old. His shoes aren't very blue. I totally outblued your shoes, man. Look at that. Jeez. You're slacking. Stop it. I'm here. It's a long discussion. It's my lack of shoes that brought me shoes. And that, honestly, it's weird, but trust me. 10 years of barefoot.
Okay. Let's see. How close do I have to hold the microphone so that Alvaro, can you hear me? Alvaro, this is the last row check. Yes. Okay. All right. Yeah. So not much update. Next slide, please. This is the one and only slide. So there was a big update made to close off on all the open action item that we knew for IETF 103. That was version 01. And it basically brought a few key things, the explanation, and then also the section on the requirements against the forwarding plane. So must for the important forwarding options, should and may for the more complex one that are more exploratory, defines how RFC 8926, the encapsulation, can be used unchanged for BRTE. And then we work the details of the comparison with BEER, offering 2 comparison options so that people can easier understand how they can, for example, use the existing forwarding plane, maybe in hardware, so that they have and just add the at this point in time CLI, and then hopefully soon the Yang control plane. And so yeah, we think the document is stable. Just wanted to stand up here and say that as the authors would like to ask for working group last call after IETF. The target is experimental, primarily because we just at this point in time just have CLI and then the Yang model. So the whole integrated thing that BEER has with the IGP and it's ready to go, that is not there, and we just don't have that much deployment experience as well. Yep, and that's pretty much it. I still have the old slides if anybody wants details.
Questions? Shep. as chair, asking Alvaro. So I know we've moved everything to standards as a group. I know we can do docs separately as experimental. The question is, would this be something if we get deployed and it moves on and it got published, could this go back to standards track?
Alvaro Tana, Routing AD. I would prefer that if you think this is going to go to standards track soon, a year, 2 years, soon, then that we do standards track from the start. Now, the last experience that we had was, I think, sort of an exception because we were at the end of the charter, really close, and we knew that everyone in the ASG and everyone else knew that the quality of the document was standards track document, even though it was marked as experimental. And then we just did the one thing and then moved within a few months, right? So if we already think that this is going to go the same way, I would rather do the work up front and not just try and do it twice.
So can I ask
that's what I would rather do.
Right. I got it. Again, Greg, as chair, asking Torles, is your intent with experimental just to lower the bar, move this thing through so that we can get it published?
So primarily because, I haven't been involved in any deployment experiences, right? So that's basically what I'm missing. I think the text itself, the due diligence that we did, we adopted it fairly late because of the rechartering stuff in the BIER working group. So there were a lot of versions already with a good review from the working group before it got adopted. So I think the document could be going for standards track, give or take whatever deployment experience may be missing.
Yeah, I don't remember, now that you mentioned the charter, I don't remember if the charter we put anything about the status of this.
No, I think included as work, not as status.
Not as status, right,
but the bar we set for standards track from the original charter was fairly high in terms of deployment experience.
Yeah, but that was the original charter.
Right, but what we moved forward is that we had vendors moving forward with this stuff, whispers,
Well,
yes.
the other thing that I see here is, there's the Yang model, there's a couple of other people talking about BRTE, so presumably there's interest, and there's maybe people doing something. I don't know.
Easy.
I'm just, waving my hands. In the end, I guess I want to set the expectation that unless, assuming that I'm still the AD, unless this goes to standards track relatively soon, I would probably like it to be, go through the work group again.
Okay.
If it takes a while before between experimental and standards track.
So just give you my input against the room to decide. If we saw the same sort of kind of whisper vendor support, things move over, and operator support like we had for, it makes sense. Yeah, we're going to go standards track. Let's go that way. So I'm totally sympathetic to your concerns.
I'm just coming with what I know. Basically, when we go for last call, we can obviously ask, what folks would think about, the appropriate adoption. If somebody thinks that standard is appropriate, then I would love to see some kind of, feedback on whatever, implementation experience people have done.
Good. All right, next question.
From Huawei, continuing with the same experimental, though the architecture is experimental, the Yang model, the PC work, they're all aiming for standards track. So that's also something that we need to sort of resolve. Is it experimental? Then all the documents needs to be
No, I don't think that's true, right? I mean, Alvaro, can you come back to the microphone? Because I had this discussion over and over, and seemingly we have a lot of Yang models that are standards for stuff which by itself may even be informational. So I don't think there is a clear relationship. Yeah.
So we've actually done, Alvaro on our routing idea again. So we've actually done some Yang models that have been published as standard for protocols that were experimental. I don't remember if it was actually one of the PIM, well, some of them, I don't remember what it was. But yes, we have published standard Yang modules for experimental protocols. Now, this sort of goes back to Greg's question before. We tried to sort of run around the process and publish this experimental, and then everything else is standard. And then the question is, why wasn't this standard from the start, and et cetera?
Well, you tell us what really the required implementation deployment experience is for standards. I mean, obviously,
okay.
we would
So that's
like to aim as high as possible, right?
That's an excellent question. Yes, thank you so much. So if you go read some RFC 2026 maybe or something, it says that there's no requirements for publishing a proposed standard. Right? Okay. There are requirements for publishing internet standards, but we're very far from it. I had asked the chairs, all the routing chairs, and I don't know if that discussion has happened here, to talk to the working group about what the working group, each working group wants to set as an implementation policy for the working group. So it was brought up at the IETF plenary 2 or 3 IETFs ago by someone who said that maybe everyone in the IETF should have implementations before we publish anything. Because of course we believe in running code. Right? Now we in the ISG believe that we can't set a blanket statement for everyone in the IETF. And in fact, I think that we can't even do it per area. In routing, we have IDR, for example, that has 2 implementations required. But most of the other working groups don't. And in many working groups, all we see the chairs do is ask, hey, is there an implementation? And whatever the answer is, we still publish. And that's not necessarily a bad thing. But what we asked the chairs to do was to have the discussion in the working group to see what the working group wants to do and sort of document that and justify it. So if this working group wants to do 2 interoperable implementations, whatever, we go forward. If the working group wants to do 1 implementation, that's fine, we'll go forward. If I know there are some working groups in routing, for example, Manet. Manet works mostly with government type customers. So they don't actually implement anything until there's an RFC. So we can't require implementations there, right? So their policy is probably going to be, well, we don't require implementations, and that's fine. So we don't want to mandate that we need an implementation or 2 or 5 or nothing, but we want the working group to discuss that. And then if the working group says, well, we at least need 1, then we at least need 1. And then it's not my requirement or the ASG's requirement or anyone's requirement. It's the working group. We need 1 for it to be standards right, or whatever it is. But that's something that you should have a discussion.
Right. So historically, when we were on the experimental, the agreement with Dalia was that we need 2 ongoing implementation, and the interoperable wasn't put in. And then we have been chartered to the standards, and then the discussion didn't happen any farther, right? What is the standard now in terms of implementation?
I think you answered your question from what Alvaro said. It's up to us. This is our work. It's our decision. I think if we go just based on semantics, we're not saying this is an internet standard. It's a proposed standard, and it's where we want it to go anyway. So that would make sense as a proposed standard, and then at some point. And it kind of fits the line of what we've got going on right now. But let's hear from this other, unless you got some more
So just to make sure, what you're saying is,
Yeah.
you're saying that you think this working group does not need implementations.
No, I'm saying we need to have this discussion currently within the group. Exactly. I'm just giving the example we had before fits that line.
Cisco. So there's also collaborative work going on with DetNet, right, regarding BRTE.
Yeah.
That has a dependency on this architecture. So also maybe, what are they doing, right? Is that experimental or standard strength?
Are you aware, Torres, what's happening in DetNet?
I mean, DetNet.
Yeah.
Well, I mean, yeah, the DetNet stuff. It's not clear to me yet. So I think the role stuff I think is maybe happening easier, but I think there is no dependency, right? They're doing derived work, and I think that's maybe how I would see it as well. So I wouldn't worry about the status here.
They're using this architecture pretty much, right?
They may, but
I don't think it's committed. Last time I talked to Lou.
Right. They do like to have ready-made RFCs so that they can then start to use them, right? So not something. I mean, just from the whole discussion, the one thing that I remember why I did like the standard stuff is that we're, I think, getting a more thorough IESG review, right? So I mean, they're being asked more. So I think that would have me personally like to see standards if we feel that the requirements are met to go there.
Jeffrey Dong from Juniper. So when BRT first came out, I read it, understood it. At that time, I didn't think it would scale. I want to know. I haven't followed it since then. So now I just want to know if the current in its current shape, does it scale well?
I think the scaling properties haven't changed, right? I think there are good explanations, I hope, for typical assignment strategies of bits so that they're used, reused even, right? So that you can do certain type of scales. But I think this is basically something that, we'll have to gain experience, right? Not everything is going to be big service provider backbone. There's mobile backhaul. There are basically, intra-data center applications, IoT, right? So there are a lot of spaces where it can go, and I'm not making a particular claim that, it will scale to the largest service provider, of course.
Okay. The reason I'm asking this is I don't know if this is a factor to consider when we decide whether it's experimental or standard track. I don't know. I'm just raising this question.
I mean, most of QoS and a lot of other cool things we have done, let's say even things like multicast. I mean, there is no multicast in the open internet, right? I mean, sure, we've managed to get multicast with Beer and so to large service providers, but universal applicability, I think, is not a requirement for standard.
Just a question.
I think. Yeah.
Thanks, Jeffrey, and thanks, Torlis. Well, we have
a comment on scaling. We have been looking at the scaling of beer and beer TE, and the scaling of beer TE is by a constant factor worse.
louder.
And the scaling of beer TE is by a constant factor worse than the one of beer. So this is not really dramatic.
We done?
Noted. All right. So yeah. So let's. What's your plan here, Torlis?
Yeah, maybe when we're coming back from IETF next week, working group last call or whatever your proper time frame is, and then basically I'll raise the question for the output as well.
Who's read the draft as it currently sits? Who thinks this work is ready for working group last call? Those who read it, who thinks it's not ready for last call? Okay, good. So it looks like we have support in the room. Note that in the minutes. We'll take it to the list. And the other discussion is in which track. All right. So we are, housekeeping time, we are 4 minutes before the break. I suggest we take the break, and everyone promise to be back here at 11:20. All right.
Load up on Rotten Tomatoes and be back, please. Okay.
No, nothing but hugs, man. Nothing but hugs.
Did the blue sheets circulate?